This video is on the objective convert from polar coordinates to rectangular coordinates. Okay, and this is the second video on this objective. I'm hoping you watched the first one because I'm just going to go right into the question and do it. Right, so again, if you want to see more about the topic, right, click on More Instruction, look at their videos, their notes, their examples, and hopefully those help you out. Alright, so we're given a point in polar coordinates, right? So this is an r value and a theta value. R is -6, theta is positive 3 pi over 2 radians. And we're asked to, translate this, convert this to its Cartesian coordinates or, rectangular coordinates, x and y. Alright, so first I'm going to draw a picture of this. Now you don't need to draw a picture. There's a very simple conversion between polar and rectangular that we can use, but I'm going to draw a picture first. Alright, so we have our axes, vertical axis, horizontal axis. Now the horizontal axis is called the x-axis in rectangular, and just the polar axis in polar. And then you have the y-axis in rectangular. Now we are given polar coordinates, right? We're given the value of r and theta, and this is -6, comma, 3 pi over 2, or 270 degrees. So remember how to graph this. Remember how to plot these points. So I go to negative. One way to do it, and a way I like. Now you could do one of two things. You could take the polar axis and rotate the entire polar axis, positive 3 pi over 2 radians, and then see where -6 would end up. Or you can go to -6 on the polar axis. There's -6 on the polar axis. I go to -6 on the polar axis, and again we're imagining that we are traveling on this circle with a radius of 6 centered at the origin. Right. And so down here, here's -6 on the vertical axis. Over here, there's +6 on the polar axis. Here's +6 on the vertical axis. So yeah, so one thing I can do, right, the way I usually do things, I know I said before I like rotating the axes, but most often I just do this. So I go to -6, so I start here at -6 on the polar axis, and then from here I rotate positive 3 pi over 2. Remember, positive angles, you go around the circle counterclockwise. So going around the circle from here, there's, positive 90 degrees, positive pi over 2, and then 180 or pi, and then 3 pi over 2. There we go. I just went around the circle positive 3 pi over 2 radians, and I landed here. Basically on, I'm on the vertical axis. Now can you see it's obvious that this point, the x coordinate and y coordinate are, 0 for the x coordinate and 6 for the y, and that's the answer. Right? So you can very clearly see it from a picture. Now it's not always easy to see from a picture, but most of the time you're going to use these formulas. Remember the relationships between x and y and r and theta. Remember, the x coordinate of some point is going to be the value of r times the cosine of the value of theta. And the y coordinate of your point in rectangular is the value of r times the sine of theta. Right? So yeah, you're going to be using these to convert from polar to rectangular. So let's use these just to double check, right, just to make absolutely certain. So the value of x in rectangular is going to be, the value of r, which was -6, right, times the cosine of the value of theta, right? 3 pi over 2. Now, hopefully you remember that the cosine of any odd multiple of pi over 2 is 0. So the x-coordinate 0, which we're seeing. And the y-coordinate will be, the value of r, negative 6, times the sine of 3 pi over 2. All right, now the sine of 3 pi over 2, right, the sine of 270 degrees, remember, starting from here, going down here, that'd be negative 1, right? This is negative 6 times negative 1, which is positive 6. So either way I look at this, the x-coordinate 0 and the y-coordinate is positive 6. All right. Okay, so this point in polar corresponds to this point in rectangular or Cartesian coordinates. And they went through basically, again, the same formulas I just showed you. All right. So again, hopefully watching me do this, looking at the more instruction when you need to, reading the answer explanations when they come up, hoping all this stuff helps you out when you're working on this material on your own. And thank you for watching.